to Transformation in Trials. Welcome to Transformation in Trials. This is a podcast exploring all things transformational in clinical trials. Nothing is off limits on the show, and we will have guests from the whole spectrum of the clinical trials community. And we're your hosts, Ivana and Sam. Welcome to another episode of Transformation in Trials. Today in the studio with me, I have Nechama Katan, who is a wicked problem wizard and also who does innovative data stuff in the clinical space in life sciences. Welcome back, Nechama.
Thank you. It's great to be here again.
And today we're going to talk about generative AI in life sciences, some of the challenges, some of the cases that we see, and why it's both scary and necessary. And Nechama, first question is, where have you encountered generative AI in life sciences so far?
So we've looked at generative AI in a couple of different cases. So the first case is your classic ChatGPT. And the challenge with ChatGPT as a generative AI tool is that it's open to the public. And therefore, large companies are very, very hesitant to put their data in. So there's a number of concerns, and they're pretty valid, about if you put data in, can someone query back what are pharma A company employees researching on ChatGPT, for example? That would be the concern. So in that situation, what the larger corporations seem to be doing is taking ChatGPT, encapsulating it internally. So you pick up the model, throw it locally, and then that model information never goes back outside to the outside world. So that allows you to have a certain amount of control over your environment. So that's the first place where we see it. When we think of generative AI, we think of ChatGPT. But really, we're seeing it in a lot of other embedded ways that you wouldn't notice it otherwise. So let me back out of pharma for a minute. If you open up Amazon now and you ask for a product review, there's a generative AI summary of all the product reviews at the top of it in Amazon. So it's embedded into the tool. So yeah.
Oh, I haven't noticed. Amazon. I need to look at that. Yeah,
I just noticed it, right? So it's in there. It's a generative AI embedded. If I download a tool called Glass on my web browser, which I can't do at work, but you can do it at home, it will take the transcript of any YouTube video. It will take the transcript of it, throw it into ChatGPT, and produce from it a summary of that transcript. Okay, so now you've got an opportunity, and I believe that Office 365 Copilot will do this. Mm-hmm. I do not have access to that yet, but where you could imagine every meeting at work that you've recorded has a transcript with it, with summary meeting notes, the highlights, and you can ask it to summarize the meeting as a blog post, as a memo, as meeting notes, as 3 bullet points. Right? Any level of that, right? So we're starting to see these types of integrated tools that allow us to do work. Other cases where people have seen generative AI in the past are things like Grammarly. That was actually a generative AI platform. It just wasn't as well known as being generative AI. And in my case, I'm actually using Databricks, has an AI assistant, which allows you to write code. So if you're in a large pharma company, even with the isolated environment, they're very hesitant to allow you to put confidential information into the isolated model. So what most people are using ChatGPT for in my space is writing code. Okay. So that's the other example of where we're using it. And the challenge there, or the things to kind of think about, is where is it integrated? And where is it distinct? So if I open up a ChatGPT window and say, write the Python code to identify the number of women at a clinical trial site, it's going to say, well, I don't know what the table is, so here's some generic Python code. Okay? And it's not actually bad. Actually, what it's going to do is it's going to write the equivalent of proc SQL in Python and say call SQL and do it in SQL because Python isn't the language to do it in. and then it's going to say, I don't know the table. So if you go to a modern data tool, and again, Databricks happens to be the one I'm using, where you have a data library. So you click on the table, and then you click on the AI assistant. It's doing two things. One, it tells me what it thinks the purpose of the table is, and what each of the columns are likely mean. So it takes all the column names, and based off of its training of data sets, it says, we think the site is the study site. Or if you have, I had a trial where there was like a column where there was like 3 or 4 options. It said, oh, this was patient status, enrolled, discontinued, whatever. So it read the contents of that column, and you use the contents of that column with the column header to make a guess at what that column meant. So you open up the tool, and you have on one side your data table, on the other side you have your assistant. Then you can write in plain English, please give me the summary of the number of women per site, or the amount of time, the time difference between 2 events. And it will find the right variables, and it will write the code because it has access to that table, and then it will zap it over to your window, and that code will actually run. And so that's the difference between a standalone tool that just kind of like, yeah, I can go through and look at it from a standalone, and an integrated tool. And we've moved since March, from standalone tools to integrated tools, and it's mind-boggling.
Yeah, and also happening very fast. I'm curious about how this changes the distribution of labor in a life science company, because it seems like we can use more layman's terms, more common language to actually discover things in data that before would have required more skills in either Python or deep understanding of the data sets themselves. What's your take on this?
Yeah, so there's a couple things that have changed with it. The first is that because I can write it in natural language, I don't need to be a programmer anymore. I need to be able to read programming. So in the life sciences, we have a lot of people, I call them Duolingo Python programmers or SQL programmers, right? So people who kind of picked it up on the side from an app, right? Like they learned a little bit of coding, but they're not really fluent. Okay. So if you have to go hire a fluent programmer, that person has invested their career in being fluent in programming and not in the content of the subject matter that they actually have. So if you take a business user and you put them in front of a tool that requires code, they panic. They panic and shut down. That's what happens. Okay. Then if you take them in front of a tool that is a no-code tool, they will create, let's say, Alteryx. I'm just using tool names just because they're right. They'll create this cute little path of my data flow. And it's a cute little visual thing, and it's drag and drop, and it's completely not portable because now they're creating something that you can't take out of the tool and run it into a data stack. And in fact, if you can write SQL, you hate those because you can't figure out what they've done. Can't figure out what they've done. You've seen this. Okay, you've seen this, right? So I've been democratizing data forever. So with this tool, for the first time, I can take a data set and an expert and have the expert ask the AI assistant, how would I write a query to query this data? And I have an exploratory analysis tool in hand, just using Gen AI. So in February, I went to a conference and I went to every vendor and said, if I have to do exploratory analysis, what tool should I use? And they're like, we don't know what you're talking about. And I said, wow. So I went and looked for tools, and there's a couple of tools out there. One does graphics and one does data munging, and I couldn't get them to work together. And the big vendors don't have anything. And they say, well, go use a BI tool, because data engineering, which is the taking data sets and making sense out of them and merging them and munging them and data munging, data wrangling is the last bastion of IT. Okay. It's gone. It's gone as a bastion of IT, because now with a tool that has access to the data and this assistant, I can now write not perfect code, but good enough code to start to access my data. And then my good enough proof of concept code can be handed to a programmer to optimize. My no code solution could never be handed to a programmer because they're like, well, why are you giving me Lego blocks? Just give me plastic bits and I'll make my own Lego blocks, right? And this allows you to then build a Jupyter notebook or something else in open source that could then be taken to any tool and be optimized. And so that has completely, and I think this tool just got released in the last month, it's completely transformed how we're going to build our business, our teams, everything.
It sounds like
programmers love it. And the programmers love it because the programmers have been sitting on their phones texting, wait, how do I write this in Python? How do I write this? Because nobody can remember all the right syntax for all the right whatevers. And so they can use it even better. So it's democratizing data engineering. And data engineering is that getting your data munged so you have the right data sets put together so that you can then graph it and display it. Graphing and displaying data is something that we've taught school-age children to do now. Like third graders are doing it in Google Sheets, okay? So that's easy, but getting that data put together, well, I need to merge this data set to that data set, and what should I worry about it? With a little bit of training and a little bit of open-mindedness, the tool will get the most of the way through the code. So they have to be able to read code kind of vaguely. Like you go to a foreign country and you're like, oh, that looks like shampoo in French. Like it's close enough, right? So you have to be able to kind of read code, but you don't need to be able to be a fluent speaker of it to use a tool like that. And the barrier to reading a language or to understanding a bits and pieces of a language versus speaking it is a huge difference, right?
I'm wondering what this means for the content knowledge or the knowledge of how things relate to each other from a business perspective. Do we need more clarity on that now? Instead of having specialists who understand, you can say, the technology part, and specialists who understand the business context specialists can now do part way of the technical tasks. What does that do to the purely technical specialists? And what does that do to the content specialists?
So the right measure is to take a technologist and marry and attach them, embed them with a business specialist, a curious business specialist, because a curious business specialist at best is going to produce a proof of concept. So before they drew something on a napkin, okay, and that had no tie to the actual data. And then when the actual data came in, what came out from the napkin and what came out from the data had nothing to do with each other. Okay, so now the business specialist can go from a napkin to, oh, wait, I've got a little bits of code here that kind of sort of work. And then you give it to the programmer. At the same time that I'm doing this democratization, I'm working with a team of programmers. And programmers who know and really are fluent in a language are magical, right? Because they're not afraid of it and they can just build it. So you do need both. You need both, but it's going to connect them because there's an overlap. So I went to an event where someone from HP said that the trick with having technology and the business in the same table is that in order to have part of the conversation, you need to understand 30% of each side. So the technologist needs to understand 30% of the business needs to understand 30% of the technology. And I think that this generative AI helps fill some of that 30%. Maybe it's giving 10 of that 30%, but it makes that barrier easier.
I like the representation of that. I'm imagining that Venn diagram and how that overlap is growing because there's more bridging between the two domains.
There's tools that will translate, right? Gen AI will translate between the domains, and so it's bringing them closer together.
And that's interesting. I'm wondering though, because programmers for a while now, back many years ago when I started in the technology space, people actually wrote their code from scratch. Then we had
Yes.
these libraries where you can take big chunks of code and reuse it for different purposes. And now we are having code generated by some of these tools. Will there be a point in time, do you think, where we don't even need programmers? Can we also generate code for different purposes?
I think that we can let our programmers do more interesting things than just write code. Right? So we didn't get rid of programmers because we had libraries.
True.
And we're still using the libraries. If you go to ChatGPT and you ask it to do something, it pulls up a library. The first thing it does is says, this is the Python library for you to use. Okay. So every point we've said, oh, we've got more technology, we're going to have fewer people. No, we have more technology, so we're expecting to do much more work. Right. So in clinical trials in the past, there was first SDV, SDR, right? Source data verification, and then it's centralized monitoring. So now let's take all this data and do a ton more analysis. So now it's going to be all that plus audit trail and metadata. We're just growing the amount of data that we're running analysis on and the kinds of analysis we're expecting to have. And the power of the analysis is just growing faster than the technology. So no, I don't think we're going to we're not going to get rid of programmers. We are going to get rid of people who just want to program.
We don't even have typists anymore either. People who only type information into a machine.
Yeah. We're also going to get rid of business people who don't want to get their fingers dirty in the data. Like, oh, no, don't bother me with the data. Right? That's gone, right? So people, both sides are going to come closer together.
And I think you're right in the development that we are expected also from a regulatory standpoint to really have the insights from the data that we generate. It's no longer enough just to say that, well, this is just the results of the trial. No, it's also about, well, how did you arrive at those results? What was the process to getting there?
Yep. What was the process to get there? So there's another use case for Gen AI. So the first one is the programmers. And it's a cheesy one, but it comes with relatively little compliance concern from legal. Okay, much less because you're just doing data engineering, generally off standard data systems, right? Everyone has the same 5 EDC systems. There's nothing confidential about your EDC system. Okay. So the second use case that Gen AI does a really interesting job of is summarizing information. So in a typical clinical trial, you identify your risks. And I'm going to go out on a limb and say that most risks live in risk universes or RAC systems or risk assessment tools, and they get put on a shelf. And I think it was E8R1 that said, no, pull it off the shelf and look at it on occasion, but it's still a risk in a system. Okay. Then you go and you generate a ton of data, and all that data becomes issues or signals, right? So the issues are signals depending on where you fit, or findings right? So the issues are signals. And now you have on a regular clinical trial, you can have 1,000 of those, hundreds of them for sure, hundreds of them, possibly 1,000 of them at any given set of analyses. Because you have them coming out of your edit checks, you're having them coming out of your monitoring visits, you have them coming out of your central monitoring platform, out of your each of your systems, right? Every one of your AI machine learning systems, every system is creating your queries, right? Like you've got them, right? You've just got tons and tons and tons of issues, and you have an issue swamp. It's quicksand. Nothing ever comes out of the issue swamp.
I love that image.
The SCDM paper takes the issues, and you're supposed to go back up to continuous improvement to your risk. But in fact, you're stuck in this quicksand swamp of all of your issues. And if you go to your study teams and say, okay, give me the summary, what's wrong on the trial? The answer is, I have 308 edit checks, data checks, and 600 risk-based monitoring signals, and right, whatever it is, right? Some huge number. It doesn't matter how many it is, because more than 50 and your human brain is gone. Probably more than 10 and your brain can't keep track of it. So, but each system is producing between tens to hundreds of these types of things. And so you've got these all here. And the question is, how do you summarize that into one cohesive picture for a site or for a study? And that's where I think ChatGPT is going to bring the biggest value once we open it up and figure out how to use it, which is taking the output from all of these issues, aligning them to all of the risks, and saying, okay, these risks are still seeing issues that are aligned to this risk, which means, by the way, we did mitigate that risk. Or I have a bunch of issues that I can't align up with any of my risks. Let's go review my risks, right? And how can I line up all of my issues so that I can then go find out if they're actually findings? Because statistical correlation is never causation. So if I go find a bunch of stuff, can I go understand what happened? Right. So now I need a monitoring visit, a site audit, something, right? I need some conversation with the trial execution people actually working it to understand what's going on there. So I think there's huge opportunities there in summarizing data, and the advantage of using chat to summarize data is that it hallucinates much less. So ChatGPT hallucinates. So if you say, hey, what is a good bio for Ivana? It's going to come up with a bio for a typical person in Ivana's role. Right? So it's completely hallucinated it. If I say, here's everything Ivana, here's every YouTube, every video transcript of everything Ivana does, tell us what you think about what are the issues she's concerned with. It's going to come back and say, here are the issues she's concerned with, based off, right? Summarizing all of the transcripts from every video you've ever done. Right? And so I think that that's where people talk about Gen AI for drug discovery. I don't see it. I think that, but for issue management and for trying to summarize problems and writing things in clear language so that we can understand them, yes, that for sure it's going to make a big difference on.
I think that might be the largest misunderstanding of what this technology can and cannot do, whether it can actually create something out of nothing completely, or whether it's a tool for taking large amounts of something and getting it clearer or answering a specific question about that amount of data.
So even if it's creating something out of nothing, it's creating something out of a huge amount of data. So the question is, do you control the inputs to say create out of this, or do you let it just create out of everything?
I would be curious because earlier on we talked about that the way that life science companies are working with ChatGPT right now is to create these small universes, small universes that are hedged from the rest of the world. Are there any downsides with creating each our own island with generative AI, or could we benefit from working across company borders?
So I think that we should be working across within industry groups, so Transcellate, Fuse, groups like that. Because really, I don't know that I want to train my best practices from one pharma company. I would much rather train best practices from all the pharma companies, all the life science companies, right? I don't want to do a best practice from one because I know that there's low, right? You're going to be a much better picture. You're also going to have less bias. So if you take a largely US-based company, then most of the drug trial data will be US patients. Take a European one, you're going to get more European ones. Someone in China is going to have China, right? And so you're going to have different types of data, different types of issues, different ways of communicating. We have global teams now. So I think it makes way more sense to not have a single sponsor building their own models, but to do the bigger model. So Transcellate isn't that old, right? We managed to do Transcellate and we did Fuse. So I don't see why we couldn't do a common large language model for clinical trials.
Another question that comes to mind is since February, since March, a lot has happened in this space. How we in life sciences tend to move pretty slowly when it comes to adoption of new technology. We're still figuring out how to work beyond paper in some cases. How can we follow along this very rapid development?
So I think there's two thoughts there. The first is that some companies in the life sciences have tried to skip from having some data to doing AI machine learning, right? So you go straight from one step to the other. You can't. You really do need to go through each step. You have to step through one to the next to the next. So I think we can play with it in safe ways to start with. Work out some use cases, watch what other industries are doing, and then making sure that in the meantime, we have the right data accessible for when we can plug a tool into it. So that's the first thing. The second thing is we can push for industry collaboration. Because I think if we had industry collaboration going on, then we would be much more. Pharma companies are not IT companies, right? So let's have some industry collaboration around what kinds of tools we want to use this data with. How do we get industry standards so we can port data around, right? All of this requires having access to data. And data access takes time. Like if you can get your data systems updated to get new data in less than a year, you're like, oh my God, that's so fast, right? Like you're not going to get it in. So the question is, can we work on getting the data access in? And then let's think about not the open up ChatGPT, that's fun, but these integrated tools where we're not trying to teach them everything. So the Databricks example is just teaching it data engineering. Pharma can teach it just pharma, or we can teach it just clinical trials, or just risk-based monitoring, right? We can limit the knowledge we're trying to teach it, and then it will come up with a much better set of answers.
That's an interesting thought that this embedded generative AI is probably closer to transforming our industry than the general generative AI. But it also makes me think, will the existing vendors, at least the ones who manage to integrate this into their technology, will they just, will it in fact be a status quo where everyone kind of adopts this new evolution of technology, but then nothing really changes in our whole landscape of systems?
Why would it not change?
Well, if we imagine that our EDC system now also has generative AI capabilities, and our statistical computing environment also has generative AI capabilities, so they remain the same. They've just leveled up, you can say. They can do more advanced things, but they're still siloed and potentially not integrated. Do we gain across the board
We
in the
still
whole?
need to integrate, but let's talk about so statistical programming. Gen AI, again, summarizing data is great. Why can't it write a CSR? Right, there's projects going on in the industry to have generative AI take a list of tables and write a clinical submission report. Okay, so that's summarizing data. So now that just takes that whole thing and it shrinks it. So now the question is, what are those people going to do? Well, they should hopefully be thinking about cool other ways to do other types of stuff with the data, or maybe data management. What does data management really do? Data doesn't get changed. It doesn't change in a clinical trial. And so what does data management do? Data management should do is identify issues at trial sites. Well, that's really study management. And in some companies, study management and data management sit together, right? But if we make data management fast, easy, and cheap with the use of these tools, then we could go spend our time having conversations with the sites about why site behavior looks different, or why do we have protocols that consistently can't be implemented? Or why do we have an ePro that never makes any sense? Or do we have certain types of assessments that the sites struggle with? We don't know that because we can't pull that data now. But if we could pull that data, we could find all that information. Is there an industry best practice for how to stack assessments? Like we could do all kinds of really interesting high-level pictures. But really, right? So that's, to me, it's not that we're going to keep status quo. It's that an embedded tool is going to, one, scare people less, and two, it's going to be much more relevant to the problem at hand. So it's going to be more focused, right? Amazon's product review, to go back to that as an example, just takes the product reviews listed for that product. Doesn't take every possible product review on a can opener. It takes the product reviews for that can opener. And it summarizes them. And so that's the power of the embedding, is that without giving the tool context, or without giving the programmer context, right? How many, you do technology, I do technology. Without context, your projects fail.
So it helps us a part of the way with making sense of the data that we have in front of us, but it does not avoid us from having to use our brains in making sure that it actually makes sense in the context that we're trying to use it in.
Yeah, it's a way of giving you context to a problem. So now I've got context at my fingertips. I should then be able to context and then syntax. So now I can think about, what am I trying to do? So I really don't think it's going to transform what we do, but and it's already transformed my life. But it's not going to destroy the world or take over. It's another tool. It's like computers.
Yeah. Or the internet. Or search.
Or the internet. Or what? Church?
Search.
Search. Yes. Google search, right?
Yeah.
I went to a concert recently, and there was a no-phone concert. And so my son came up with some statement, and we were like, how do we verify it? We have to remember to check our phones after the phone. Whoa, how do I verify some random fact?
Well, Nechama, I think this is a perfect segue to the question that we always ask our guests on the show. And that is, if we gave you the transformation trials magic wand that can transform one thing in our industry, what would you wish for?
Exploratory data analysis. I want to have data at the fingertips of the people asking the questions so that we can really dig into the data and understand what the answers are. And I think we're one step closer.
We are getting so close, and that's a wonderful wish.
Yes.
Nechama, if our guests have follow-up questions to you about our topic or yourself in general, or have a wicked problem that needs solving, where can they reach out to?
LinkedIn is the easiest place, or at wickedproblemwizards.com.
Awesome. Well, thank you so much for coming on the show.
Thank you very much. Great.
You're listening to Transformation in Trials. If you have a suggestion for a guest for our show, reach out to Sam Parnell or Ivana Rosendal on LinkedIn. You can find more episodes on Apple Podcasts, Spotify, Google Podcasts, or in any other player. Remember to subscribe and get the episodes hot off the editor.